So our goal here is to verify this identity. And I do believe that we have the freedom to manipulate either side, but not both, right? And you know what? I actually prefer to manipulate the left-hand side. Could I manipulate this? Sure, but I'd rather play with this here. And that's just my preference. And that's what I'll do. But if you want, you could reverse engineer what I'm going to show you, and you can manipulate this side instead if you want. But I think we have the freedom to pick either side. So let me try this one here. So what I'll do is I'll leave this alone, and I'll just manipulate this here. Now, I know that this is the verification of an identity, but when you do that, you can use other identities. And if you look through your list of identities, cosine 2x is the same as cosine squared minus sine squared. Look through your list of identities, and I guarantee you that's one of them. How this became that, okay? And we do have permission to pull all the other identities out and to play with them. So that's what I did here. Now, let me throw this at you. I'll leave this the same, cosine squared minus sine squared. But now, you know what? Look, you see this 1? Do you know what I'm going to do with that 1? I'm going to write it as sine squared plus cosine squared. See what I'm saying? And I do this because the sine squared and negative sine squared actually eliminate. So I'm left with 2 cosine squared, right? Because cosine squared plus cosine squared. Now, if I feel like doing this, I can write this as 2 times 1 over secant squared, right? Because the 2 is a 2, and cosine squared is the same as 1 over secant. That's fine. So this is 2 over secant squared theta. And you can probably already see how that we're about to be finished because 2 stays the same. But one of the identities is that secant squared is the same as 1 plus tangent squared x, which of course equals this. So that's me doing this side. I'm sure you could manipulate this side and do sort of a similar argument, but I'm pretty sure that what I've shown you holds true.